My name is Sakina. My metric number is 183 160.
Okay, my name is Sabrina and my metric number is 181578.
Okay, my name is Alphonse Gomez. My metric number is 185170.
Hi, my name is Laura Samson. My metric number is 183628.
So we're making the videos of. We're going to talk about our project, which is the mechanical system of exoskeleton of upper limb. So we start with Lola.
So basically, what we want to find, the criteria that we want in our upper limb exoskeleton, which is first is the simple and precise. The first criteria. The second one is the material that we want to choose. The third one is the function, and that's it. It's all about. Okay. First I'm going to talk about the simple and precise, which is in terms of simple, we more focusing into design, which is it will be more easy to handle for the user, and it for the mechanism, it's just a straightforward mechanism, so that it will not confuse to the user how they going to use that exoskeleton. So for the material, we're looking for a light material and a cheap, so that it will be affordable, and for the people that does not have high income can also afford that our exoskeleton upper limb. And then, okay, the real thing is the function of the exoskeleton upper limb, which is the most important thing that we want in our exoskeleton is this product will add some power. Is basically it's more into force. It will add some force into arm area, which is it help to it will give additional force when
we want to stretch hand. No, it's like when you want to
Look up something.
you use your arm, like you want to, like, what they call,
want to harvest that fruit from a higher tree.
Have like that.
Then the third point is it will increase the efficiency of work done by the arm. And basically, we want to produce a exoskeleton that does not require any electrical power to run the mechanism. So it just we back to the first point, which is a simple and precise. We just want a simple mechanism to produce the exoskeleton that we want, and it is a friendly user because it will not lead to injuries to the user. And since it is easy to handle, it will not it will not confuse the user how to use, and so it is a self-teaching.
Self-teaching.
So basically we already choose we have sketched some idea, which is 3 sketches. And we already chose which one is the most better. Before that, we want to explain about the first
two
first sketches.
we have.
The first 2 sketches.
Yeah.
Okay, so let me support astaga.
Oh,
Teruskan.
Okay, so the first one, this is the sketching of mine. It's a little bit ugly, but it's the best that I can draw. Anyway, okay, the system will have like a back support. Oh, okay, before I forgot, this my design is actually more toward like electronic design, so it's not going to be chosen. Okay, for my system, I have like the back support, and then you have like the mechanized arm, and you also like have the knee pad. It's like I showed the first time in the drawing. And then so how it works is that on the shoulder area we will use like the Nemtech pulley, I mean the batch reel concept, but it is more like the measuring tape concept, because when you pull it and then you will when you want to stop at a certain level, you push like the first button. I mean, for my design I have two buttons, the positive and negative. The positive one is for you to like pull forward your hand, and the negative one is for you to like take back the things that you want. Okay, so yeah, that's all about my sketches.
Okay.
So for our second idea, we have the crutch. The crutch, the one that we use when you have a leg injured, you cannot walk.
It will give us extra support to the upper limb.
Well, here's what we do. You see, it's something that you use when you have a leg injured and you cannot walk. So you have a need support from the upper limb. So we have this idea because we think this is kind of help your upper body, upper part of your body when your leg cannot, when your lower body cannot function well. So this we think that it might help. So we think it's quite relate to the title that
Exoskeleton,
the
which is
project.
the exoskeleton of upper limb.
Because it gives support to the upper limb, gives support to the arm, especially to the arm, to the shoulders, the upper limb part. So but we're not going to choose this because
It's really
we cannot really relate what to the kinetics. So we don't find it really suitable with our project. So we choose the best one. This is not the best one. So that's all in the talk.
okay. We
So
move to
next,
the sketch 3, which is the one that we're going to choose, and Alphonse going to
this is what we already
explain.
choose. And
So I'm gonna discuss about this one. This is what we've chosen, and then basically it's a simple experiment and uses simple principle. And this is an example.
This is the batch reel.
This is the batch reel.
The
And then
basic concept.
the basic concept, you just stretch. You use it. It obeys Hooke's law, so it stretches, so it stores energy. So what we consider is just to fix it somewhere here, and then by stretching it, it will give force, and then in doing so, it will give you power to pull up something, as my earlier presenter said, that it gives you additional power to plug out something backwards. So we agreed on choosing this drawing, this simple sketch. So basically we came up with some of these equations, Hooke's law. So Hooke's law is equals to F equals to Ks. So since this batch reel is storing energy, so it stores potential energy, but as the user starts moving it, he starts exhibiting kinetic energy. So we relate kinetic energy with the Hooke's law. So we came up with potential energy equals to half Kx square, where K is the constant,
Coefficient,
the coefficient, and the X is the displacement, which is the displacement and the compression. So the displacement length and the compression, so which is the X. So and then for us to calculate that, we also came up with another equation to find for the velocity, because as we are stretching it, it is moving at a certain speed on certain time, so which is V equals to half Ks square. So using these two equations, theoretically we can calculate the angle, but then as you can see, the way I'm stretching my hand, it is moving at an acute angle, which is less than 90 degrees. So we consider it to be less than 90 degrees. It could be 45, 30,
somewhere from 0 to 90 degrees.
So that's what we came with. So we hope we will able to design something like that to help in terms of, especially in agricultural, like oil palm plantation, where it will help the user to,
Help the harvester to pluck the fruit from the old palm.
That's the main idea.
This is what we agreed on. As you can see, this is the drawing. This is that idea we all agreed
Attach
on.
at the shoulder.
The shoulder.
Shoulder of the user, then it stretch to the.
So that's our concept. That's our project idea. The main idea that we came out with. So I think that's all from us. Thank you very much.
Thank
Bye.
you. Bye.